All right, so 6.4 will be just, again, right triangles, and then we'll move on to any triangle. So we'll review again stuff we've already done before. It shouldn't be too crazy. But we'll add to the stuff we've already done. Okay, so the first few problems in the homework are going to give you some triangles, diagrams. So you got to find the missing sides, missing angles. Since it's a right angle, you can use Pythagorean theorem, but all they want is theta. So like we did those word problems, we said choose a trig function. So there's theta. I have an opposite side and a hypotenuse, so we should use sine, right? So sine theta is equal to 10 over 50, which is basically a 1/5, right? Now, do sine inverse of both sides. So sine inverse of both sides. To cancel the sine. So now I get theta, these cancel, equal to sine inverse of 1/5. Now I'm going to stick to degrees just so it's a little easier, not because I like it. Okay, so sine inverse of 1/5 is going to be 11 something. Yeah. 11.54 degrees. So the first few problems will be something like this, and then after that, they'll throw in some word problems. Is there any questions on these steps here? It's straightforward. Is it weird?
Okay, so if it's a 25 or 30, would it just drop down to the lowest number?
I mean, you could just leave it as 10, the big fraction in there, it'll still work out. But if you said 25 over 30, that would reduce by a factor of 5, right? 5 over 6. So you can plug either one into the inverse, and it will understand. Okay. Let's do a word problem. We've kind of already done this type of stuff. I don't want to spend too much time on this. So we get to the harder ones. So a 40-foot ladder leans against a building if the base of the ladder is 6 feet from the base of the building. Is 6 feet from the base of the building. What is the angle formed between the ladder and the building? Okay. So let's start drawing this out and figure out what the heck are they asking for. A 40-foot ladder leans against a building. if the base of the ladder is 6 feet from the base of the building, what is the angle formed by the ladder and the building? All right, so let me draw this building. There's my building. Got a 40-foot ladder on there. And the base of the ladder is 6 feet away, right? It's not drawn to scale. How long is the ladder? So you would put the 40 right there, right? Now, what angle are they asking about?
You're
Yeah.
asking about, oh, yeah.
They asked about the angle, right? So you have to know which angle. One up top, one on bottom, or one over here.
One at the, but it says the building and the ladder.
Yeah, it has to be here, right?
Yeah.
We don't choose this one because that's the right angle, right? And this is not on the building, so we're looking for this guy. We'll call it theta. So now that we have our angle, use a trig function, and then use this inverse idea to solve for theta. Okay. So opposite is over here, hypotenuse is up there. So we should use the sine. So sine theta is opposite over hypotenuse. So sine inverse of both sides. 60 over 40 reduces to 3 over 20, right? And that's it. Theta is equal to sine inverse of 3 over 20, which is approximately something. 8.63. Yeah, that's not great. Any questions on how we set this up and why we chose sine and how we found theta? Is it okay? You also have some pre-cal equations after some word problems. Let's do that next. Oh, I'll wait a bit. So next example. So we'll start with something that we don't need inverse functions for, because you can, I think last time we saw these, or some of them, most of them, with the unit circle. So let's do it both ways. So the restriction that the book put on us says find all angles between 0 degrees and 180 degrees. satisfying the following. Okay, so part A, this is something we've done before. Square root of 3 over 2. Now, if you look at the circle, you should see there's two answers, right? Let me put the circle up real quick. Right, when is sine equal to square root of 3 over 2? Well, at 60 degrees and 120 degrees, right? You can see right away the answer. I'm going to show you how to do it without the calculator. I mean, without the circle. All right, so technically the process is supposed to be like this. Sine inverse of both sides. Let's keep it in degrees so you can see it right away. Theta will equal, you said it's 60, right? The calculator should give you 60. Remember the inverse functions can only spit out a value between the right half of the circle, positive to negative. So it can only give me this one. It cannot give me the 120. So we'll call it theta 1. The second one will be 180. So this is the rule. You just subtract from 180 to get the other. Okay. So whenever you're doing the sine inverse, just subtract from 180. So these are the answers that we already knew from the circle. But doing the work, calculator gives you this one. This one is found by subtracting with 60 degrees. Okay. So let's do one where that's not in the circle so you can see how it works. Let's say sine theta is equal to 0.4. Right, so we have no choice now but to use our calculator. Just gotta do it. So sine inverse of both sides. The theta will equal to sine inverse of 0.4, which is approximately something. Yeah, so it's going to be 23 point, we'll round to 58. 23.58 degrees. So we'll call theta 1 equal to this. Theta 2 will be 180 minus this answer. Okay, so that's what you're always going to do for sine. Just subtract from 180 when you do a inverse sine.
Is it only for sine?
Yeah. Cosine will be from 360, which we'll do in a little bit. Any questions on the process? Okay. Let's do one for sine, or cosine, so you can see. I'll pick an easy one again. This is on the circle. We should know that the answer is also 60 degrees, right? So let's pretend we had no idea. We do the inverse of both sides. So theta would be equal to cosine inverse, which becomes 60 degrees. So to get theta 1, so this is theta 1. If they wanted theta 2, you would have to subtract from 360 for cosine. if we look at the circle, we'll see the answers, but we're only going to choose this one because we were only curious about 0 to 180. But technically, there's two locations. Okay. Yeah.
That one's subtracted from 360, but the other one's from 180.
Just the way they're defined, sine is stuck over here, so I can't get any values over here. So I got to subtract from 180. Cosine is all the way over here, but I can't get any values down here. So you subtract from 360. So it'll always work out for you. Just remember, if you use inverse sine, do 180. If you do cosine, do 360. You're basically finding a what's it called? Cosine. We found 60. Yeah, here it is. So we have this value right here, 1/2, and we know the other one's down here, 300 degrees. It's the only one to get there. Subtract from 360. Excuse me. Anyway, it's only this guy because of what they said. Any other questions on example 3? Keep those ideas in mind. Should be okay when solving for the angles. Okay. You guys cool on this page? All right. So the next few questions, I'm for sure going to put on your exam. So notice how here they don't match up, right? So they can't just cancel or whatever. So what you're gonna have to do is pull a triangle based on this information. So you agree that cosine functions take angles, right? So this inside thing is some angle. So what you can do is say, let theta be that is inside garbage. Okay, so, and we also know that inverse functions will give you an angle. The theta is equal to sine inverse of this. Now, if you use the definition for inverses, or if you take sine of both sides, however you want to think about it, sine theta would be equal to 3/5, right? This is by a definition. Right, so I labeled it and then used the definition. So now that you have sine, right, what they're asking for, right, I substitute my theta, they want to know what is cosine. Right, that's the actual question. This thing up top is asking you, what is cosine given this information? Right, so just build your triangle. Go and build my triangle. So sine is equal to opposite over hypotenuse. Solve for this side, or notice that it's a magic triangle. So it's going to be 3, 4, 5. That means that cosine would be adjacent over hypotenuse. So that's all you're going to do. 4/5.
Question.
Yes.
Where did the
Pythagorean theorem. If you solve for the missing side here, since this is a right triangle, you're going to get 4. But after doing these doing many of these triangles, you'll notice that if you see a 3 and a 5 there, there's always going to be 4. It's one of the special common triangles. But if you solve it, it's going to be a whole number. Once you have it, just plug in the definition of cosine, adjacent, hypotenuse. Any other questions on number 4? So it's a little weird. Once you see it, it's not too bad. But yeah.
Can I find the angle at first, like sine inverse 0/5, and I will find the angle, and then I can just plot the angle, with the cosine, like cosine the angle, and I will find the side.
You mean like changes to the value? Like
Yeah,
an
sine
actual angle?
inverse 3/5, for example, like whatever angle I would get, I'll put like cosine the angle, and I will find the side in this case.
You could, but if I ask you to give me an exact value, you have to give me exact values. I don't want to see any approximation or decimals. You know what I mean? Like, don't punch into your calculator. The exact question will say exact, meaning no calculator nonsense. Does that make sense? But that is technically what's happening. It is an angle going inside the cosine. Technically. Any other questions?
So the answer is the ratio, it's not the degree.
Yeah, the answer is 4/5.
Right.
So using this information, you find cosine. And you want to learn how to do this, right? Because this next question has no numbers. So you have to. For example, cosine inverse of u. Right? There's no other way. Have to build your triangle. So let theta equal to cosine inverse. Use your definition. That means that cosine is equal to some u. There exists a theta that will make cosine equal to u. My definition. Build your triangle again. It's technically u over 1. Right, so write it this way just so you can see that this is adjacent hypotenuse. You can always put a 1 underneath anytime you want, so it's invisible. So here I can use it. Now, find the missing side. Let's do the Pythagorean this time. We'll say u is the a here. T will be 1. Solve for b. Right, so subtract the u over. 1 squared is 1. Square root both sides. B is equal to 1 minus u squared. Square root. Okay. So the question is really asking, what is sine theta, right? So sine will be opposite over the hypotenuse. And that's it. Any questions on this problem? We do one more just in case. You guys will clean this page. All right. Example 6. Let's do tangent of cosine inverse of u. So same deal here. Theta will be the cosine. Cosine theta is equal to u. Build a triangle. I choose the theta to be there, so adjacent is here. Hypotenuse is there, right? Because this is over 1. When you do Pythagorean theorem, you're going to get the same thing as earlier. We'll skip that step this time. So now the question is really asking, what is tangent? So tangent of cosine inverse of u, which is equal to tan theta because I renamed it, will be opposite over adjacent. Any questions on this last one?
Is 6.4.
Yeah. This one. So we'll start 6.5 now, and then we'll leave some time for questions if you have any. Yeah, of course. No rush. Got it?
Just a second.
Did you say where our exams will be next week?
For sure next week. I don't know what day yet. I'll know by Wednesday. I'm leaning towards Monday or Wednesday. Earliest it will be Monday. Okay. We'll see. That's cool on this page. Last section is 6.6, which will finish Wednesday. So let's start 6.5. So in this section, they start to move away from right triangles. Now it's any triangle. And once you leave right triangles, you no longer have Pythagorean theorem. So you can't use it. So please don't use it unless you have a right angle. I know someone's going to do it. They always do. Please don't be that guy. The trig functions can also be used to solve oblique triangles. No right angles. Using the law of sines. Okay, so here's the formal formula or definition. So given an ABC triangle, let me draw you a picture. It's not an isosceles triangle, that's the only one I can draw. They all look like this, they're not. So any triangle that's not, like it does not contain right angles, right? Some kind of triangle. This looks like they all have the same angle. But it doesn't. So capital ABC will be the angles. Opposite to those angles will be the sides of lowercase a, b, and lowercase c. So those are the sides. The formula says that the following ratios are equal. This is the law of sines. Sine A over A is equal to sine B over B, which is equal to sine C over C. So when you're solving for an angle, use this one. If you're solving for the side, you can use this one. Little a over sine A equal to B over sine B equal to C over sine C. If you use this for sides, you have less algebra steps. But you can just use this one if you want. So just giving you a recommendation. Okay. Case 1. So these are the 4 cases for solving triangles. You're only going to do case 1 and case 2 for law of sines. So you need to have one side and 2 angles. We call these angle side angle or side angle angle. Case 2. Case 2, you have 2 sides and an angle opposite to one of those sides. Two sides and an angle, 2 sides and an angle opposite to one of those sides. Call this SSA. So case 1 and case 2 is law of sines. Case 3 and case 4 is law of cosine, which we'll talk about Wednesday. Just go ahead and write it down now. 2 sides and the included angle. This would be SAS. Case 4 is nothing besides 3 sides, no angles. So use law of sines for cases 1 and 2. So if you don't have either of those cases, you can't use it. Okay. Now, if you're trying to use this on a right triangle, it's going to end up simplifying into a Pythagorean theorem anyway. Okay. All right. Any questions on these definitions?
And the last one's SSS.
Yeah, there's 3 sides.
Okay, and the first one is ASA and SAA.
Angle, side angle, angle. 1 side and 2 angles is case 1. Case 2 is 2 sides and an angle opposite to one of those sides. Case 3 is 2 sides and the included angle. Case 4 is just 3 sides. So you
And
These, yes.
okay, so I'm using that top triangle for the one case.
Well, when I define sine A, I'm referring to this A. So whenever you build these ratios, it has to be sine of an angle you choose over the opposite side. So that's where it's written this way. Sine A over little a, sine B over little b, sine C over little c. See how they're all opposites.
Yes.
Just to keep everything straight. This is some generic triangle, and that's how the formulas are built. There's ratios to the opposite sides. So we can choose any of them and say equal to whatever you want. So like I said, this one equal to that one, vice versa. Depending on what you need to solve, you choose whatever you want. So let's start solving something. Example 2 in the book. You guys pull on this page. First example. So we'll just do one, and then I'll leave time for questions and whatnot. I'll let you guys think about this before I make this hard. Solve the following triangle, or harder, I should say. So it's an SAA type. So in this example, they actually give a picture, which is nice of them. I'm going to see if I can draw it. Try to draw earlier. Let's see. Yeah. Whatever. Okay. So A, B, C. They gave me angle A, or sorry, angle A and C. I do not have B.
So you
25 degrees and 20 degrees. And they give me no side, none of the sides except little c, 80.4. That's all they gave us. So they want us to solve the triangle, which means find all the angles, all the sides. So the way I like to start is just write down everything I do have. So capital A, I have that. Capital B, I do not. Capital C, it's 25. Then I'll write the corresponding sides. I do not have a little a or a little b. Little c is 80.4. Okay, so I got everything that was on this triangle. So now I'll use your formulas. So I'm going to use this guy because I have an angle and its opposite side. I'm going to use this to find little a because this has the angle but not the side. So you want to pick something that has only one unknown. If I set this guy equal to these two, then I have two unknowns, which doesn't help me. But before we do any of that, what's capital B?
135.
Yeah, 135, right? You guys see why that's 135?
180 minus 35 minus 2.
Yeah, the sum of the angles of a triangle has to be 180. So subtract the two angles you got, and you'll have B. So that's technically given to you, right? Almost. So now we have capital B. So all we really need to do is find two sides. So start the ratio. The law of sine says that little a over sine A, I can set that equal to this one, little c over sine C. Kept it in general. That's what the formula says. They're all equal. I'm going to isolate little a in general terms and then plug everything in after. So just multiply both sides by sine A, right? Both sides by sine A. These cancel. So A is equal to C sine A over C. plug everything in at that point and use your calculator. So 80.4 sine 20 over sine, this should be a sine C down here. Huh? Sine C. Okay, so we isolated little a so we can find it, obviously. Plugged in all the angles and the side. 25 right here. This is 20. This is 25. Okay. If you have an older calculator, put everything on top in parentheses, 80.4 sine 20 divided by everything on the bottom, sine 25. Should be 65.06. We'll round to first decimal place, I guess. So little a is 65.1. Any questions on this first step here?
Are you doing the exact same thing?
A little bit? Yeah, we're gonna do the exact same thing. I'm gonna set this guy equal to a little b over sine b.
This is arbitrary sine multiplied by, so for instance, we would have sine C multiplied plus, or C over sine C multiplied by sine C and done the opposite.
If you were solving for like trying to isolate little c, yeah, you could do that. Yeah, you can do whatever you like. You have an equation, just make sure you solve for the thing you need, right? You'll be fine. So I'm trying to set it up with the least amount of steps. So little b over sine b, because I need little b. Setting it equal to the one they gave us. I like to use the one that is given in the problem because I didn't round those, they did. So I feel better about it. Especially if they're exact. Because if I try to use these numbers here, that might throw off my calculation for a little bit because I'm going to be rounding again. And I already rounded once to get this. So it introduces error, which is just how it goes. Okay, so C over sine C. Solve for b, and you're going to end up with c sine b over sine c. I multiply both sides by sine b. I didn't show it this time. Plug in c and all the angles. So what is that?
134.5.
134?
Yeah, 0.5.
Yeah, that's right. And that's all the sizes and all the angles, and then that's it. Any questions on this step here or this one? So here I'm solving for here I solve for b. Okay. Does have any homework problems or issues? I reopened 6.1, so apparently I didn't hit save or something. So it's open till tonight. If you need if you haven't already, if you already did, don't worry about it. But I told everyone that I'd open it Sunday night, and then it wasn't open. So it's open till tonight. 6/2 and 6/3, I think you're closing at some point soon, so don't forget. I'll close 6, 4, and 5 either today or tomorrow. Well, we'll stop here. If you have any questions, let me know. You can stick around for a bit. If not, see you Wednesday. We'll finish chapter 6 then. Yeah. We haven't finished it. Yes.